So, hi everybody and welcome back. This is a C++ tutorial series for absolute beginners. This is video 144, and in this video we will continue with our repetition of the keywords, and we're trying to learn a little bit the syntax as well. We extend these keywords a little bit, so we learn, we are not doing just repetition, we are learning also new stuff and so on. But here, before I go on with our keywords, I want to mention one more thing which is probably important for beginners. And what is this? The number 44, here we talked about these strange cases where I showed you that you should run this program code and you should run this program code, and we had errors, right? And the number errors, of course, we can't have number errors later if you are using numbers and many numbers. And then I showed you a website like this, where you can read about this floating point format, the precision, and the other one is that. And when you watch this one and try to search a little bit how this error is avoided or something like that, then you will see that also some people will mention you should understand this here, where this arithmetic about floating point arithmetic. And the problem with this sites is, as a starter, these are all written in mathematical scientific explanations. Let's call it. It is all time explained in a mathematical way, which means it is not very useful for programmers if you have not learned base high mathematics. What I mean with base high mathematics is, let's watch this example here, for example. This one here, he is explaining in a mathematical way with proofs and theorems and so on why this floating point arithmetic makes so much problem. The problem here is he's explaining it with mathematical explanations, and if you don't know high maths, you will not understand this very nice. Even so, you say, hey, he is explaining it with words. That's not true. When we go here a little bit down, you will see he starts with this abstract mathematical explanations, and then you see this math formula here, and then he tries to goes here and makes some, let's go here a little bit down. You will see that he's going from normal examples to this kind of stuff, this theorem, then this proof, and all this kind of stuff you learn more or less in math, in high math, because you should learn how to prove something. But not only in math, there are different sections too where you learn proofs, but this one is a math proof, and this kind of stuff is very difficult if you don't know it and have never learned it. And to learn it takes a lot of time, because you need math, I don't know, this high math you need, and you don't learn high math, for example, in normal school. You learn in normal school this plus, minus, multiplication, division, and so on. So what I want to tell you is, actually, you don't need all this kind of stuff. Why you don't need this and why they are showing this. The point is here, what they are doing is they are showing this for more or less engineers. We are programmers, we are not engineers. What is the difference about engineering and programming? The difference is, if you go for engineering, you need to learn high math, which they will teach you in universities or other institutions where you go. And the reason for that is this kind of proofs what I showed you here, that works most time with the stuff like in math, right? So this proves, they make theorem, and then they prove that if you need this one, and especially here with numbers, we are talking here about floating point numbers and something like that. Of course, there are also physical explanations, but physics needs maths anyway. But there are some sections which needs not math at all. and has this kind of stuff too. I will talk about this in a moment, but let's continue here. And what I want to point out is this one here is just engineering. Engineering means you need to understand this, and this kind of stuff you learn in high maths in university, or you just learn it by yourself. You can teach yourself this as well, but that takes time. And we as a programmer, we don't need this. But if you say this official, let's say, this is unofficial. When you say this official, you don't need high maths. Most programmers say you need high maths because you need to prove this kind of stuff. And actually, this is not true. And the reason why I say it's not true, like I said, this kind of stuff is more for engineering purposes, which means if you go to the section where you want not program, let's say where you want try to engineer or invent something new, then you need, of course, methods to make sure that all works and don't waste time. And this math here, what they are true is anyway just an approach or a presentation of one way to do this. And yeah, and the question is here, why then all say we need this in in programming later when you try to go to university, for example, they say you need this kind of stuff. And the reason for that is university and programming are not the same. Careful about this one. University has most time another purpose than teaching programming. They are not really teaching program. Most time, the persons who go to university, they know already programming. They can program already. They are not going to university and they are not learning this high math because they need it in programming. That's not the purpose. And that's very important here to tell and to understand. If you understand this is very good. If not, that's also good because you will learn it. Yeah, so with that said, I will not go on too much here, but I want just say, if you don't understand this, all this talk here, what they are talking it here and what they are talking in this proofs here, don't worry. This is not very important for a programmer because a programmer, we as a programmer, we don't care about these proofs. We are using the proofs, right? That's the point about programmer. What is the difference about understanding the proofs and using the proofs? The difference is anyone, let's say, people who have already proved this one and one way, they publish this kind of stuff and then you can use it. And that's enough to understand as a programmer. Then you will say, okay, we have errors. For example, this whole site here explains how there are errors and how you can avoid these errors and how you can make it less errors and so on and so on. But that's enough for us as a programmer to understand. Not for us, it's not important to understand, okay, this one is caused by this one and this one is caused by this one. So, okay, I understand you proved it. You are right. There are errors. We accept it just and say, okay, you have proved it. Cool. And now, as a programmer, I would say I'm just interested in the solution, not how you have proved it, how you showed all this kind of stuff. Just say me a solution, how I can. When I go back to our example, let me show you this one again. Copy this one, go to main. As a programmer, I'm only interested, let me uncomment this one here. I'm only interested, and start this program here. So understanding this one is nice because we have an error here, right? You have to understand this one, that this occurs an error after this point. But I'm not interested how this errors is described, right? More or less, for example, this site will explain you how this kind of errors occur and why it occurs in a mathematical way, which will lead you to more, which can make it much more complex than it is. But as a programmer, I say, okay, I understand. We have the precision, okay. there will occur errors from a certain point of precision, but I know that there are some people, engineering people, they have figured this out. They found solutions to a certain point. And me as a programmer, for example, I'm not interested in now that you explain me all this kind of stuff here and explain me the math function here, which I don't care actually right now. And all this kind of stuff for us, for an engineering part, of course, he must explain this to other engineers and he must prove that all this kind of stuff is true and so on. But like I said, we as a programmer, we want only the solution for this one. First we have to know, okay, there is an error from a point, and now I'm interested, yes, what I have to use. Right? What I have to use to solve this one. When I work with high numbers, what I have to do. And these are the questions which a programmer is really interested in, and not this kind of stuff which gives you a headache, which will waste a lot of time if you are not interested in engineering, because this kind of stuff is more for engineers which will deal with the compiler building. For example, if you are interested in compiler building, then you might be interested in this kind of stuff here. And then you have to probably learn this because you are working then with the hardware. You try to figure it out, and then you try perhaps to prove this to other people and so on. So I think I talked again too much about this, but what I want to say in short is, if you know math, what is taught in elementary school, which is something like plus, multiplication, minus, or division, that's enough. And if you know the numbers, let's say from minus 1000 till 1000, you have already the math what you need for programming. At least if you know this one. This is so the minimum things. If you know this kind of stuff, you will be able to program, and you don't need high maths. So, and yeah, and how I'm sure about this one, that you don't need high maths, like I said, university and schools, they are not teaching this kind of stuff. I mean, they are not teaching really programming. You should already know programming when you go, for example, informatics. They are teaching other things, not programming itself. You already should know this kind of stuff before you enter this kind of schools. Or if you teach yourself, don't care about this high stuff, high math, because a programmer, like I said, needs not really math. You will, but here one thing I should notice: you will need all this kind of stuff if you write a program which is the topic of math. For example, I write here, I don't know, I simulate anything which contains only math, because think about it, programming is more or less let's say, in short, it simulates the world, and the world has many different aspects, right? One is math, one is words, one is whatever you want to make, one it's graphics, one it's this, and we don't care. And so if you know basic maths, perfect, because it is already proven that, and now I make also a proof that if you don't know any high maths, you can write perfect programming. And some kids which are 40 years old kids, 50 years old kids can already program write super programs better than some professors in the university, because you don't need all this kind of high maths in this kind of stuff. That's the reason why they can write this without knowing nothing about all this kind of reasons. But careful, I'm talking about programming, not engineering. If you're asking engineering questions, of course this kid will know nothing, because engineering means all time you need this understanding of math. This is one let's say conventional presentation of all countries. Then you need this yes, this high maths, because they are communicating with all in the world with this high math presentation. That's a problem there. When you go to university, you have to learn for engineering purposes this kind of stuff. Of course, for other purposes too. For example, for proving and something like that too. So, and there was the last thing what I talk here. So first, we don't need math in programming. Only if you dive into numbers and make heavy arithmetic things, then you need math, of course. But programming means you can program whatever. For example, if you program an app or just my database, what I showed you, or just a login account or something like that, most time you don't need programming. And if you need programming, like perhaps you need sometimes calculation, but we as a programmer, we are not really interested in understanding what is the calculation here. We are more interested in the result, which means just give me the library which calculates this one and I use it. That's it. That's it. Very fast, without thinking what it does. You should only know that this library does it what you want. That's it. And then you can skip all the math things here. And yes, you're just asking yourself, does this calculation solve my problem? And for example, here is this numbers here, and we have a problem. What I'm doing as a programmer is I find just a solution for that. I'm not understanding now. It's nice that you can understand this one, but I'm asking, okay, what is the solution for this problem? How we can solve this? Which means what I have to use to solve this precision, or what I have to consider to solve this precision, problem here. And there are different approaches how to solve as a programmer this kind of stuff without understanding anything here like that if you have problems. So that's that. I hope you understand. This is very important. I know I talked much here, but this is very important because many people say you need math in programming. No, you don't need math in programming. The only math you need, which I showed you, is something very simple. When you can go school math, which is very simple most time. If you know this, if you know plus minus multiplication and so on, then you are very good with math, because in general you don't need much math. Well, what you more need is how to find a solution, and most time there is already made a solution. The only thing when you really need math perhaps is, like I said, you go to university and then you are aiming for engineering. Engineering topics and so on. They need this one for global communication, because math is one way to show, and it's the easiest way, I think, because that's the next thing what I want pointed out. Math is not the only presentation of this kind of stuff. You can present all this math here actually in words too, right? And many people don't like, there are people who like words more. For example, you can express this kind of stuff here, what is so compact and looks abstract. For example, if you don't know high math, you say, oh my god, what is the symbol here? I don't know this. What is this meaning here? Or this symbol again here, and oh my god. Then you say, I have no clue what the symbol is. I mean, if you have never learned this symbol, then you will not understand this equation here, right? And what I want to say is all this kind of stuff you can even convert to words, but I mean not math words, logical words. And an example of this one is, for example, if you ever read philosophy, they are making actual logical proofs as well, but not in math way. They make it in logical writing words, many words, all these philosophical proofs. And then you read pages, or you read almost one book just for a one proof. And that's the problem with the words. And that's why math is a little bit better. If you convert, for example, this thing in words, you need pages just to describe this one. But if you use math, you just describe this in one line, for example. And if all those guys who learned math, high math, they will understand it. And that's why math is, let's say, preferred in engineering instead of using words, because like I said, in words you need pages, but it's easier to understand probably for some people because they don't like this abstract presentation. But because these words would go step by step. And what I mean with words is actually, let me show you this one too. Perhaps you understand this one. It's very easy. For example, you say, oh my God, what is that here? We have here, let me scroll this up here a little bit. And here, we have here something like that, right? He says here anything like that. Of course, you can analyze this step by step and understand it easy. First of all, what is this plus minus here? Which means just you can use plus or minus. You have to test it in both. And then you try to understand this block here step by step. What means the starting point 0? Okay, this one is a starting point, and then you analyze this really one by one, and you can convert this also in words, and that will take much time, but yes, it's possible. But in the end, you will realize learning this math, it's much faster than converting in words, because words take pages. This one take just one line. That's the difference. Yeah, but yes. So, and my last thing what I want to say is, we as a programmer don't care about proofs. We are using the proofs. So we have here a problem. Here on this side, they say if you want to understand this one, for example, why there is a problem, you can read this one, but you will understand only this kind of stuff if you know, if you want to understand the proof. Me as a programmer, for example, I don't care about the proof. I just say, okay, what I care is there an error? Yes, it happens. There is an error. What you have to know as a programmer, let's say so, that there are errors and you have to figure out when this error starts. So just check numbers and then read in a good book where the errors are, but don't care about the proof. You just need where the errors start, and then you need countermeasures, which means how I can solve this. For example, let me start this one here. Then you can ask, oops, this is doing nothing because I have not copied this. But anyway, what I want to point out is how we can avoid this. Then you're just asking not what is the proof of this one or why is this happening. You are asking as a programmer how I can avoid this, right? This is the question which you are interested in. You want to solve it. You want to go on and not, and you know that there are people who already figured this out. The only problem you can encounter is that one people had not figured it out. This is very rare. This would be something like if you invent something new, which is not, let's say, discovered or something like that. But this is very rare in the rare cases. In general, there are people who already found different kind of solution. And you can, for example, solve this solution. You can Google on try to search machine and then write in how to avoid this one, how we can solve this one, and then you will see there are many solutions and so on. So I think I talked much just about this thing here, but that's very important because I wanted just point out you don't need math, so don't be afraid if you are bad in math, because there are many people who don't like, let's say, high math, this abstract presentation. And if you try to read, for example, this side here, because when you Google on-site, many say understanding this floating point, you have to read this one here. And if you start reading this one and don't like math or don't have understanding of math, then this one will give you a collapse. But, and that's why I talk so much. Don't worry about all this kind of stuff. As a programmer, you don't need it. You need just to know how to solve this problem. And of course, you have to know that there is a problem with this floating point numbers. And then you try just find a solution. That's it. That is what you do as a programmer. And that's it what you do in general with math problems. find the solution, not invent and try to understand the math, how it works, because that's most time not interested. At least in many cases. That there are some other cases where, when you, like I said, when you work with many numbers, and these numbers, yes, are anyway mathematical functions or something like that, where you use math as a topic, then that's another story. So with that said, I talked just too much about this one, and that's why I stop this video here and start with the repetition actually in the next one. So we make this one as a separate video, and then I start with this one here. It was too important, and the reason why I did, like I said again, I know there are people who are programming but don't have the knowledge about this math, and they think that they are not able to program because they don't know math, and that's absolutely not true. You don't need math. Don't worry about this too much. Just program, because programming is much easier when you think without math, because a programming means programming language and not math language. Just think like that. All right, with that said, I stopped this video. It was strange video, but I hope it helps some people out there. And yeah, if you have any questions or any complaints like all time, write it in the comments. And in the next video, we continue, but with our repetition of the keywords. And see you there. Bye and good luck.